Let's try another example with subtracting fractions, again by looking at the LCD. Notice that our LCDs are second power in this problem, and when you're dealing with any denominators that have a second degree of x or higher, we need to think about factoring them first. Our first denominator has x squared minus 1, and we might notice that this is a binomial, but it is a binomial that has perfect squares. Two perfect squares with a negative sign between is the special case of a difference of squares. Our difference of squares formula says that we'll break this into two parentheses, x plus 1, x minus 1. Now, our second term is also second power, but it is not one of our special cases. Instead, because we have a binomial with no special cases, we'll look at what they have in common. Since both of those terms contain an x, we will pull an x to the outside and then divide both of those terms by x. X squared divided by x is just x to the 2 minus 1 power, or just x, and then minus x over x just gives back the number 1. So our factored form of the second denominator is x times x minus 1. Now let's have a look at our denominators. We have a binomial, x plus 1. We have another binomial, x minus 1. We have a monomial, x, and then we have a repeated binomial, x minus 1, which we've already seen before. If we're going to try to write an LCD, that LCD must contain the monomial I've circled in red and both binomials. It will not be enough to write one binomial or the other. We have to write both binomials. Even though the only difference between them is that there's a sign change, that is enough to where we'll still have to write both of them. However, it's still not enough just to write the binomials. We have to put the monomial in there with it, because a monomial and a binomial are not the same thing. However, the second occurrence of x minus 1, which I've underlined in yellow, we don't have to write it twice. The fact that we already have x minus 1 written previously is enough, so we'll write x plus 1, x minus 1, and x. So we'll say our LCD will be x, the monomial, times x plus 1, the first binomial, x minus 1, the second binomial. Before we go any further, let's rewrite our fractions with the denominators in factored form. Our first fraction was 2 over x squared minus 1, but we rewrite that as x plus 1, x minus 1. Our second fraction was 3 over x squared minus x, but we changed that to x times x minus 1. Now let's compare our fractions' denominators to the LCD. Our first fraction has x plus 1 and x minus 1, so it's already most of the way there. The only thing it's missing that the LCD has is x, so we'll multiply by that on the top and bottom. Let's write in the x on both the top and the bottom. The second fraction has 3 over x times x minus 1. This fraction has the monomial x and one of the binomials, x minus 1. Therefore, it only needs x plus 1. Therefore, we will write x plus 1 on the top and bottom. With this in mind, let's combine the fractions. We'll have 2x minus 3 times x plus 1 on the top after we put these terms together from the numerator. On the bottom, we'll still have our LCD, x times x plus 1 times x minus 1. When we combine these fractions, now we'll try to simplify the numerator, but don't worry too much about simplifying the denominator. To simplify the numerator, we notice that we have a monomial. In this position I'm pointing to, the negative 3, and we're multiplying it times a binomial, x plus 1. This means we will need to distribute the negative 3 to both of those terms. Therefore, we'll still have the 2x to start with, and then negative 3 times x is negative 3x. Negative 3 plus 1 is negative 3. This will still be over our denominator, x times x plus 1 times x minus 1. Now we'll combine 2x minus 3x. This is because they have the same degree of x. If we do this, we will have negative x minus 3 on top, and still the same denominator, x times x plus 1 times x minus 1. And now we have successfully combined those two fractions with the subtraction sign in between.